do this back for homeworks, or is that why we, oh, okay.
I will.
Cool.
Yeah, I'll probably do it in lab.
Okay.
I might do it today if you remind me.
Okay.
What's the difference between physical and chemical changes? What's the ultimate difference?
The chemical changes change composition of matter.
Yeah, I like that. Chemical. What's another way to say that? Its composition changes its what?
Chemical makeup.
Okay. Chemical makeup or its formula. So if it's chemical formula, it's changed. If its composition is changed, then it's a chemical change. What are those three things that let you know that you probably just witnessed a chemical change?
Change in color. PPT.
Formation of a precipitate.
PPT is that abbreviation for precipitate. Okay. In that gas formation, I just want to make sure we're clear that I don't mean bubbles from heating a liquid. That boiling is not that kind of situation. We're talking about just mixing two things together and all of a sudden you get bubbles. Can you give me an example besides the that one we talked about with the vinegar and the baking soda that maybe you've experienced? And I do mean experienced. You have actually experienced the bubble formation.
Alka-Seltzer tab
Oh, that's a good one. It happens in your stomach. You might feel that bloating of the Alka-Seltzer tab. I was thinking something a little bit more visceral.
Hydrogen peroxide on a cut.
Hydrogen peroxide on a cut. No bubbles, bubbles. It didn't boil that hydrogen peroxide. The oxygen came out of that hydrogen peroxide right there in situ in the wound. So
What about sugar? Like when you boil sugar?
when you boil sugar, no. Wait, I'm sorry. Who's boiling sugar?
Like if you boil it in like this, is it not
You're taking sugar and putting it on a pan and boiling it?
Make simple syrup that way, in some Thai food.
Really?
Uh-huh.
No water whatsoever. You just put sugar on it and boil it? That's dangerous. Yeah, it's definitely gonna have a color change, but it's I didn't think the stove got hot enough to boil that. Melt it, yeah, but boil it, really? I have to try that. Yeah, that's probably a chemical change only, but because you know before the bubbling, because there's a color change as well. Okay. One more thing on the color change. Let's say I mix two things together and one thing is red and one thing is clear and the whole solution becomes pink. Is that a color change? We're okay with that not being a color change, right? I've got Kool-Aid, it's too raspberry flavored and I dilute it down, it's still Kool-Aid. All right. How about this unit?
Standard of measurement.
Yeah. So the measurement part's really obvious. Why is the standard part important?
Everybody uses the same thing.
Everybody knows what everybody's talking about, right?
Yeah.
Okay. Development of the metric system.
Kings have different size feet.
Because we wanted it to be standard for the whole planet. Planet standardization. That was one of the funny things about I was reading about the frequently asked questions about the lunar eclipse last night. One of them was, where do I have to be to see it? And the answer was just Earth. As opposed to the solar eclipses where like you gotta be in a specific place to see it. Not the lunar one.
Oh, how often do solar eclipses happen?
Solar?
Oh,
It varies. They happen not that infrequently, but you have to be in a specific spot on the planet.
okay.
That lunar one's like another 30 years. system, what's this whole system based on?
Tens.
Tens. All right, so I'm gonna move the decimal place on this, and which direction am I moving it? To the right. So 2, 3, 5, 8, and then 2 zeros. Do I put a decimal place there? Before I mess around with the answer, how many sig figs are in the given value? 4. So how many get to be in the answer? 4. If I put a decimal place right here, what's that say? That all of those are significant and it's 6. So if there's no decimal place there, then you can't assume that those 2 zeros are significant. Scientific notation for this next one. It's a number, the first number, a decimal place, the rest of the numbers, and then times 10 to the, and in this case, what do we got? 4. So really, when we're looking at this, let's say that first one, for example, I've got that answer and then the given, those two things are exactly equal to each other. So what we're saying is in the given value, that if I take that 2.358 and I do what to it? What am I going to do to it to make it equal to the answer? I'm multiplying it by 10, 5 times. That's it. That's all we're doing with scientific notation. How many times do I multiply or divide to make the decimal number and the scientific notation number equal to each other? So that second one, I'm going to take that 6.5895, multiply it by 10 4 times, and then I'm going to get what I started with. Okay, what am I doing with this next one? 3 spots to the left. I'm going to put a 0.005894. All right, so this thing right here, this 0, mathematically it means nothing. So a 0.02, that first 0 doesn't mean anything. The second 0 is at least a placeholder. There's no significant figure associated with it, but it's a placeholder. But in the world of healthcare, they do that. So you will not write a number down. If the number is either of those two numbers, you will put a 0 in front of the decimal place, or you will be berated by somebody. Pretty much it. Nope, I'm just telling you that you will, it's not awesome being yelled at by like a doctor in front of a bunch of people because you forgot to put a number down. So don't do that. Even though you could say, you know, mathematically, it doesn't mean anything at all. It's just, that's the way that they do it. Okay, so this next one here. What do I need to write?
9.23 times 10 to the negative 4.
10 to the negative 4. Yep, that looks good. Okay, so we're going to convert this 285 inches into meters. We're going to use the railroad track method. And to go from the English length to a metric length, what do I have to use as a conversion factor to swap between the systems? That's centimeters to inch. So it was nice. I gave you this 285 inches, and so immediately I can swap over. So where does the inch unit need to go to cancel? All right, so I'll throw an inch down here, and then I ask myself, can I go from inches into something else to get me closer to meters? And so centimeters is that answer, and so it's 2.54 for 1. The inches cancel, and then I'm going to go how many centimeters for a meter? 100. And the centimeters cancels, and the only thing I'm left with is meters, and this is, what is it, 7.24?
Two,
7.24?
239. That's what I got.
But then you gotta do the significant figures, which is 3, so 7.24.
Yeah, so the answer was 7.239, but how many sig figs did I get to start with?
3.
That 2, 8, and the 5 is 3, so my answer can only have 3 in it. So I go 7.23, but there's a 9, so then that rounds that up to a 4. So I'm going to convert feet per second into miles per hour. And so my miles per hour, it's like 24.7 0.5 feet per second. Doesn't matter which one we do first. I'll put the feet down here, and then we can go straight from 5,280 feet to 1 mile. The feet are gone, and so I have miles per second, but I want miles per hour. I'll put 60 seconds here for 1 minute, and then I'll put 60 minutes for 1 hour. Minutes, seconds, those are gone. What do we got here? Anybody have an answer? I don't remember.
88,000.
No.
16.7.
Yeah. Think about that one though for a sec. 24 feet per second, is that fast? You could run it. Can you run 88,000 miles? Yeah, okay. When you get your answer, like, does that even make sense? Definitely be asking yourself that. Okay, this last one is definitely a healthcare question. What am I looking for in this?
Correct answer.
Milligrams.
Milligrams.
You're looking for milligrams for your answer, right? So I need milligrams, and so I was only given milligrams in one of these numbers, so that means I'm going to put 20 milligrams per 0.5 milliliters. Okay. And that's great. I have the milligrams right where I wanted in the railroad track. My answer is going to have milligrams in the numerator, but I need to get rid of the milliliter that it came with, and so I have this other 6.2 number, so I'll take 2.6 milliliters here, cancel out those milliliters. I'll just be left with milligrams. And we got a number for this one? 52? Is that what you said?
It's not
It's like 30 something. 34 point.
666.
Yes, it would just be 35 because it rounded to 53.
It was 52 over 1.5. They were saying
It's really gonna make me do this. 20.
34.666.
The ones that are getting 50 aren't dividing by 1.5.
20 times 2.6 divided by 1.5. Divided by 1.5. The answer to this is 35. Because the 34 rounds up, 34.6 rounds up to 35. Because technically there should be a decimal there. Are we good with that?
So we just round it to 35 even?
Yeah.
I have a question.
Yes.
On, the first conversion, the 2.358 times 10 to the 5th, you put a 6 in there?
Did I?
Yeah, I'm not sure where it came from.
Okay.
Right? 235,860? And
That's
it's
supposed to be a zero.
Oh, okay.
Come on, that's so obviously a zero.
Okay, I was like, where did that 6 come from?
Right? That totally looks like a 6. Is that better?
No.
Is that right? How about that?